So now we will come to something known as the molar mass. We already know what is the atomic mass. Atomic mass is the mass of one atom of any element, and it's listed in what units? AMUs, atomic mass units. Molar mass is the mass of one mole of that particular element. So if you take fluorine again as example, what's the mass of one atom of fluorine? The mass of one atom of fluorine is on the periodic table 19.00 AMU given here. 19.00 AMU. That's the mass of one atom of fluorine. But what's the mass of one mole of fluorine atoms? If I was to ask you what's the mass of 1 dozen of fluorine atoms, you know I'm talking about 12 fluorine atoms. So if I say what's the mass of 1 mole of fluorine atoms, how many fluorine atoms am I talking about? I'm talking about the Avogadro's number of fluorine atoms, which is 6.022 times 10 to the 23 fluorine atoms. What's the mass of that? And why is this relevant to us? It turns out that the Avogadro's number is not just any number that the scientist Amadeo Avogadro arbitrarily chose. It has a directly something to do with the AMUs of any given atom. If fluorine, the mass of one atom of fluorine is 19.00 AMU, the mass of 1 mole of fluorine atom is the same number, just the unit would be in grams. So mass of 1 mole of fluorine atoms is 19.00 grams. So that's 19.00 grams plus per mass of fluorine atom, and this is known as the molar mass. The molar mass pertains to individual elements or each substance, as we'll see soon. So when we talk about the atomic mass, we are talking about the mass of each atom, such as lithium having a mass of 6.941 AMUs, carbon having a mass of 12.01 AMU. Well, what's the mass of molar mass? What's the molar mass of 1 mole of lithium? That's 6.941 grams. What's the molar mass of 1 mole of carbon atom? That's 12.01 grams. We can actually do a simple calculation to see this. And so we already know that one atom of fluorine weighs 19.00 AMU. Now, if we multiply it by the fact that 1 AMU of fluorine has a mass of 1.661 times 10 to the negative 24 grams of fluorine, which we did previously in the previous problem, we'll see that the AMU of F on both sides cancel out. And we'll do one more multiplication. This time we will relate this mass of fluorine atom in grams to what's the mass in what's the Avogadro's number. Okay. And what we will get is 1 mole of fluorine atoms has 6.022 times 10 to the 23 atoms. What can cancel out now? Can you see something that can cancel out? Atoms of fluorine here and atoms of fluorine here cancel out. Remember, only the denominator and a numerator term cancel out. They are on the they are in the fractional form and they will cancel out. It's very basic math. And when you do this calculation, as I had told you for chapter 1 metric conversions, you want to put everything in parentheses. Put this in parentheses, put this in parentheses, and then put this in parentheses. And when you do this calculation, you get a number, and that number is 19.00 grams. Okay, so this is how we arrive here. Turns out that you don't need to do this kind of calculation for every atom, but if you want to do as a practice, I highly suggest you try this with any other atom. If you try this with lithium atom, where you would have 6.941 AMU of lithium for one atom of lithium, times the same number here, because 1.661 times 10 to the negative 24 grams of lithium would be the mass of one AMU of lithium. And when you do this kind of calculation, you would arrive at the same number but with the units of grams. Okay, so that's the molar mass. Molar mass is the same value, same number as the AMU mass, except in units of grams. Why do we care about this? We care about it because when we step in the lab, we are measuring everything in grams. If I ask you as your lab instructor to go get some fluorine, fluorine is a gas by the way, but let's assume that there was some substance and it has the same molar mass as fluorine, 19.00 grams. And so if you obtain 19.00 grams of fluorine, what you need to know is how many moles there are or how many atoms there are. Then you can then relate to how many atoms there are, how many moles there are by doing this kind of calculations in the reverse direction. Ultimately, all chemistry happens at counting level. You are counting individual number of atoms, and we will learn about why that's the case in the next section. But first, let's practice a little bit more in finding the molar mass and then what we can do once we have the molar mass. We did previous chapters, we did calculations with density to convert between grams and milliliters. Then we also saw how atomic mass unit converts between AMUs and grams. We saw how Avogadro's number converts between moles and number of atoms in this chapter. And now, right now in this video, we saw how molar mass, or we will see more examples of it, how molar mass converts between grams and moles. So here is an example. Calculate the number of moles of sulfur. S stands for sulfur. Calculate the number of moles of sulfur represented by 1.81 times 10 to the negative 10 to the 24 atoms of sulfur. That's a lot of atoms of sulfur. But how many moles is it? How do I find that out? We saw here in this slide that the relationship is going to be between the Avogadro's number. In order to convert between moles and atoms, you need the Avogadro's number relationship and the moles of the atom. So 1 mole of sulfur has 6.022 times 10 to the 23 atoms of sulfur. And this will be true for any atom. If I say like I told you previously, if I have 1 mole of humans, that's 6.2022 times 10 to the 23 humans. If I have 1 mole of marbles, that's the same number but in marbles. Similarly, if I have 1 mole of sulfur, that's that many number of sulfur atoms. That gives me these two forms for the conversion factor, and one of these two forms will be multiplied with this value here, just like we learned in our metric conversions. We start with our starting value including the units and we multiply it with one of these two. Which one will it be? We want our final answer to be in moles of sulfur, and we want to cancel out the atoms. Because this number up here is going to be in the numerator, we want one of these two conversions to have atoms of sulfur in the denominator. Which one has that? That's right, the first one. So when I multiply this thing with this, the atoms of sulfur cancels out. The unit that remains is moles of sulfur, which is what we are asked to do. Calculate the number of moles of sulfur. So when we set it up correctly here, we are cancelling out the atoms of sulfur with the atoms of sulfur. This is in the numerator, this is in the denominator, they cancel out. And if you plug it in correctly by putting parentheses in your calculator correctly, the answer will be 3.01 moles. So how many moles are there in 1.81 times 10 to the 24 atoms of sulfur? The answer is 3.01 moles. Pay attention to the significant figures here as well. We got 3 sig figs here. This is, think of this as 4 sig figs, although this number can have more digits, but we have rounded it to 4 sig figs. This is an exact number, so we should have, in our multiplication, we should have how many sig figs? Equal to the number with the least number of sig figs, which is this one, 3 sig figs, 3.01 moles of sulfur. Okay. Now what is the mass in grams of 3.01 moles of sulfur? How do I find that out? If we look over here, the last one, molar mass converts between grams and moles. Okay, we use this part, Avogadro's number, to convert between moles and number of atoms. From the number of atoms of sulfur, we found the moles of sulfur using the Avogadro's number. Now we have the moles, 3.01 moles. We want to know how many grams is that. Okay, and that's when we'll use the molar mass, and we'll have a molar mass conversion factor. Okay, and the relationship which you can find on the periodic table is 1 mole of sulfur equals 32.06 grams of sulfur. Now how is this relationship on the periodic table? Why do I say that? On the periodic table, under the column for sulfur, number 16, you will see the number 32.06. Previously I said that that's the atomic mass. One atom of sulfur weighs 32.06 AMUs. But like I said in this video, that the molar mass is the mass of 1 mole, and it's the same number as the AMU mass, but in the units of grams. So 1 mole of sulfur weighs 32.06 grams of sulfur. That's your relationship, and these are the two conversion factors that you get. Which one of these two will you use to multiply with this value in order to get the answer in grams? If you said number 2, the second one here, then that's right, because the moles of sulfur here and the 1 mole sulfur here, they are same unit, they will cancel out. And so when you do this correctly, what do we get? So, did I go here? So here is the answer, 96.5 grams of sulfur. And so that's the desired result. Now, why did we introduce the mole? This example problem will make it clear. When you step in the lab and sulfur happens to be a solid under most conditions, if I ask you to go and retrieve 96.5 grams of sulfur for some experiment in a test tube, for example, you can find out how many moles it is by using this conversion factor in reverse and multiplying it by 96.5 grams, which will tell you this many moles of sulfur. And once you have the moles of sulfur, you can find out exactly how many atoms of sulfur there are by using this conversion factor in reverse. And once you have the moles, and this conversion factor in reverse will tell you this many atoms. So basically what you are able to do is find out exactly how many atoms of sulfur there are in your hand when you retrieve 96.5 grams of sulfur without counting, because counting atoms would have been impossible. 10 to the 24, which is the number of sulfur atoms, 1.81 times 10 to the 24, is such a huge number that you cannot count it. But since chemistry happens at the counting level, we need to know how many individual atoms there are. But you don't sit down and count. It would take you billions of years, if not trillions. Okay? Even if you can count very fast, we don't have time to do that kind of math, but it's true, to reach that value. And you cannot even see a single atom. How would you count? But using mathematics and creating the conversion factor of the molar mass conversion factor, we can convert between grams and moles, and then using the Avogadro's number conversion factor, we can convert between moles and atoms. Okay, so from grams to moles and from moles to atoms, and so that's what we can do. But in the previous example, we went from atoms to moles and moles to grams. Here we are told we have 1 gram of sulfur. How many atoms there are? So that's exactly what we can do here. We can go from grams to moles and moles to atoms. Cannot skip any step. So what's the conversion factor we use between grams and moles? We use the molar mass conversion factor. And what's the conversion factor we use between moles and atoms? We use the Avogadro's number conversion factor. And here is that setup: the molar mass conversion factor and the Avogadro's number conversion factor. The grams of sulfur cancel out, numerator, denominator. The moles of sulfur cancel out, numerator, denominator. And if you put parentheses around each of this, the answer is 1.88 times 10 to the 22 atoms of sulfur. Here are some more practice calculations you should do before you attempt the before you try the exam and the homework and the quizzes. Calculate the number of atoms in 1.7 moles of boron. So I will just tell you a few things. You are going between atoms and moles. So what's the conversion factor you use? Will there be 2 or 1? The answer is just one conversion factor. The Avogadro's number conversion factor. Now here in the second problem, find the mass in grams of 2.5 moles of sodium. How many conversion factors here? Again, just one. And what's that conversion factor? It's the molar mass conversion factor. You need to look on the periodic table for the mass of sodium in grams. I believe it's 22.99 or 22.98 grams for 1 mole of sodium. Then here, calculate the number of atoms in 5 grams of aluminum. Here you will use both conversion factors. From grams you will go to moles, convert the grams of aluminum to moles of aluminum, and using the Avogadro's number conversion factor, convert the moles of aluminum to atoms of aluminum. Then calculate the mass of 5 million atoms of gold. So here you want the answer in grams. Whenever it asks for mass, you want it in grams. So from atoms to moles will give you the number of moles using the Avogadro's number conversion factor, and then from moles of gold to grams of gold using the molar mass conversion factor. Here is a slide that tells you exactly the 3 conversions from one to the other. You can go from grams to moles and then moles to atoms, and depending on exactly what you are working with, later on you will see something called formula units and what we learn called molecules, then particles as well, but generally particles is not something we will come across a lot. We'll definitely see molecules and formula units. Molecules have to do with covalent compounds and formula units to have to do with ionic compounds. So you can convert from grams to moles, mole to particles or atoms, and from atoms to moles and moles to grams. And here is how the conversions happen. Avogadro's number. In one case you multiply by Avogadro's number the mole times this, while here you divide by Avogadro's number. You flip this conversion factor upside down. Similarly here you are to go between moles and grams, you are multiplying by molar mass, grams per mole, and here you are dividing by molar mass, 1 mole over the number of grams, if you want to go to the right. Okay? So look at this slide, study it, and do this for practice problems, and be prepared for this kind of calculations are going to be found left and right in our work in this course.